Hello students, today we are going to learn about a new chapter, that is data structure from CS1. This chapter explains the basic terms related to data structure. Data definition defines a particular data with the following characteristics. Atomic definition should define a single concept. Traceable definition should be able to be mapped to some data element. Next is accurate. Definition should be ambiguous. Clear and concise. Definition should be understandable. Now, what do you mean by a data object? Data object represents an object having a data. Now, what do you mean by a data type? Data type is a way to classify various types of data such as integer, string, etc., which determines the values that can be used with the corresponding type of data. The type of operations that can be performed on the corresponding type of data. There are two types of data types: built-in data type and derived data type. Built-in data type. Those data types for which a language has built-in support are known as built-in data types. For example, most of the languages provide the following built-in data types: integers, boolean, that is true or false; floating, that is decimal numbers. Now, character and the string. Now, what do you mean by a derived data type? Those data type which are implementation independent, as they can be implemented in one or the other way, are known as derived data types. These data types are normally built by the combination of primary or built-in data types and associated operations on them. For example, list, array, stack. Now, what are the basic operations in a data structure? The data in the data structures are processed by certain operations. The particular data structure chosen largely depends on the frequency of the operation that needs to be performed on the data structure. Transversing, searching, insertion, deletion, sorting and merging. These are the operations which take place in data structure. Now, stack is a type of data structure. A stack is an abstract data type commonly used in most programming languages. It is named stack as it behaves like a real world stack. For example, a deck of cards or a pile of plates, etc. A real world stack allows operations at one end only. For example, we can place or remove a card or plate from the top of the stack only. Likewise, a stack ADT, that is abstract data type, allows all data operations at one end only. At any given time, we can only access the top element of a stack. This feature makes it last in first out data structure. LIF stands for last in first out. Here the element which is placed inserted or added last is assessed first. In stack terminology, insertion operation is called push operation and removal operation is called pop operation. Stack operation may involve initializing the stack, using it, and then deinitializing it. Apart from these basic stuffs, a stack is used for the following two primary operations. Push, pushing, storing an element on the stack. Pop, removing an element from the stack. When data is pushed on the stack, to use a stack efficiently, we need to check the status of stack as well. For the same purpose, the following functionality is added to stack. Peek. Get the top data element of the stack without removing it. Is full. Check if stack is full. Is empty. Check if stack is empty. Or at all times we maintain a pointer to the last push data on the stack, as this pointer always represents the top of the stack, hence named top. The top pointer provides top value of the stack without actually removing it. Now in detail we can learn about a push operation. The process of putting a new data element onto stack is known as push operation. Push operation involves a series of steps. Step 1. Checks if the stack is full. Step 2. If the stack is full, produces an error and exit. Step 3. If the stack is not full, increments top to point next empty space. Step 4. Adds data element to the stack location where top is pointing. Step 5. Returns success. Now pop operation. Assessing the content while removing it from the stack is known as a pop operation. In an array implementation of pop operation, the data element is not actually removed. Instead, top is decremented to a lower position in the stack to point to the next value. But in linked list implementation, pop actually removes data element and deallocates memory space. A pop operation may involve the following steps. Step 1. Checks if the stack is empty. Step 2. If the stack is empty, produces an error and exit. If the stack, step 3. If the stack is not empty, assess the data element at which top is pointing. Step 4. Decreases the value of top by 1. Step 5. Returns successes. Now queue is an abstract data structure somewhat similar to stack. Unlike stacks, a queue is open at both its ends. One end is always used to insert data in queue and other is used to remove data, that is requeue. It follows first in first out methodology. That is, the data system stored first will be assessed first. A real-world example of queue can be of single lane one-way road where the vehicles enters first, exits first. More real-world examples can be seen as queues at the ticket windows and bus stops. Now the basic operations. Queue operations may involve initializing or defining the queue, utilizing it, and then completely erasing it from the memory. Now, what are the basic operations associated with the queue? In queue, that is add or store an item to the queue. The queue, that is remove or access an item from the queue. Now, few more functions are required to make the above mentioned queue operations efficient. That is peek, get the element at the front of the queue without removing it. Is full, checks if the queue is full. Is empty, checks if the queue is empty.